Behind all the big headlines about international summits and treaties, there's this sort of invisible network that's always humming in the background. It's this whole global ecosystem of scientists and diplomats, and their work is shaping pretty much everything, from how we fight pandemics to how we deal with climate change. Today, we're going to pull back that curtain and really dig into the fascinating world of science diplomacy.
Right. So if you want to see just how powerful this all you have to do is look up. Back in the 80s, we were facing a disaster, a massive hole in the ozone layer. So what happened? Scientists provided the cold hard proof of what was causing it, and that evidence led directly to the Montreal Protocol. It's one of the most successful international treaties in history, and it happened because science had a crucial seat at the diplomatic table.
All right, so here's the game plan for this explainer. We're going to take a tour of this whole science diplomacy ecosystem. First, we'll nail down what the term actually means. Then we'll zoom out to the global level. Think the United Nations. After that, we'll zoom right back in to see how different countries do it. We'll meet the folks on the front lines, and then we'll tackle the big one, the huge pressures the system is under right now.
Okay, so first things first, what do we even mean when we say science diplomacy? Because it's way more than just scientists from different countries chatting. It's actually a pretty sophisticated tool, and it works in three really distinct ways.
At its absolute core, this is it. It's about using the universal language of science, which, doesn't really care about borders or politics, to tackle problems we all share. And maybe, just as important, it's about building relationships and trust, especially when political channels are, let's say, a little frosty.
Let's break that down a bit. People usually talk about three dimensions. First, you have science in diplomacy. That's when a scientific report lands on a diplomat's desk and actually changes a treaty. Then there's diplomacy for science. This is all the behind-the-scenes work, getting visas, securing funding, and making the agreements that let massive projects like the International Space Station even exist. And finally, science for diplomacy. This is where you use that scientific teamwork itself as a way to build bridges and open up communication. They all feed into each other, creating this really powerful cycle.
All right, let's start our tour at the very top, at the highest level, the United Nations. This is where science diplomacy happens on a massive, multilateral scale, with pretty much every country on the planet involved.
Yeah, it's easy to think of the UN as just a political forum, but it's also a gigantic engine for scientific governance. It has all these specialized agencies that are basically the arenas where scientific facts get hammered out and turned into the global rules and standards that affect all of us.
And here are some of the heavy hitters. You've got UNESCO, which really fosters that collaborative spirit. The World Health Organization, which we all know coordinates global health crises. The World Meteorological Organization, making sure everyone shares weather and climate data. And the IAEA, which handles the incredibly delicate job of nuclear verification. Each one has a very specific, very critical mission.
This is just a perfect example of science for diplomacy. The Sesame Project is a cutting-edge research facility in the Middle East, and under the neutral flag of UNESCO, it brings scientists together from places like Iran, Israel, Jordan, and the Palestinian Authority, all working together side by side. It's an incredible bridge built entirely out of science. And you can't talk about science in diplomacy without mentioning the IPCC. I mean, this is the ultimate example. They don't even do their own research. Instead, thousands of scientists volunteer their time to review and synthesize all the existing climate science. What they produce is a consensus report so powerful, so authoritative, that it becomes the undisputed scientific bedrock for huge global treaties like the Paris Agreement.
Okay, so we've seen the global picture, but how does all of that connect down to the national level? How does a single country get its act together to play on this stage? Well, it usually boils down to two main structures. On one hand, you have these big, prestigious national science academies. They're independent, they're autonomous, and their power comes from their pure credibility. They give the long-term, impartial advice. But on the other hand, you have a much newer idea, science advisors who are actually embedded inside foreign ministries. Their job is to give real-time scientific advice to the diplomats making decisions right from within the system.
And what's wild is just how new this is. The whole idea of a dedicated science advisor for a foreign minister only started in the US back in 2000. And even by 2017, only 7 countries had one. So it's a tiny club, but it's growing fast.
And to help it grow, these advisors have started to form their own networks. A great example is something called FMSTAN, the Foreign Ministry's Science and Technology Advice Network. It's basically a way for them to share notes, figure out what works, and build a global playbook for this brand new field. Okay, let's zoom in even further. Let's go right down to the people on the ground, the ones working at this intersection every single day. We're talking about the science attachés working in embassies around the world.
It's one of those job titles that sounds really cool, right? A science attaché. But what does that person actually do all day? It's not just about setting up student exchanges. It's this really unique mix of deep scientific knowledge and sharp diplomatic skill. I mean, just imagine their job. One morning, you might be reading a dense new paper on AI and have to explain its national security implications to your ambassador. Then, that afternoon, you're trying to connect a top university from your home country with a research lab in the host country, navigating all the red tape. They are talent scouts, translators, and advocates all rolled into one. They're the scientific conscience of the entire embassy.
And not everyone does it the same way. The U.S. tends to use a diplomat as expert model. They take career diplomats and train them in science policy. This makes sure they fit right into the embassy's work. France does the opposite. They have a scientist as diplomat model, where they'll take a senior scientist and just appoint them to a diplomatic post. This gives them huge technical credibility right off the bat. Two totally different philosophies.
So, we've painted this picture of this amazing, collaborative, global ecosystem. But it is now facing, without a doubt, its biggest challenge ever. We're in a new era of intense geopolitical competition, and it's threatening to tear this whole thing apart. This quote just nails the problem. For decades, the default assumption was that science is a global good. But now, that's being replaced by suspicion. The open sharing of research is more and more being seen as a national security risk. And there is no better example of this tension than the relationship between the United States and China. Just look at these numbers. For more than a decade, the US and China were building the biggest scientific partnership the world had ever seen. Then, around 2017, it's like they hit a brick wall. The US launched its China Initiative, which sent a real chill through the academic world, and collaboration just nosedived. A drop of nearly 20% in just a few years, that's a massive, massive change.
So, what's the way out of this? Well, one idea that's gaining traction is this concept of smart openness. The idea isn't to just slam the door shut, but it's not about being naive to security risks either. It's about finding that strategic middle path, collaborating on huge global problems like pandemics, while building strong fences around really sensitive areas like military tech.
And really, this is the tightrope that science diplomacy has to walk today. Every single country is constantly trying to balance its own national interests, economic strength, security, with the common interests of humanity, like not letting the planet overheat. The whole challenge is finding that narrow little space in the middle where you can serve both, because that's where all the progress happens.
Which leaves us with this final, really tough question. For a long, long time, openness in science was seen as a massive strategic advantage. It attracted the best minds, it sparked innovation. But today, that same openness is often being framed as a critical weakness. And figuring out the right answer here isn't just going to shape the future of diplomacy. It's probably going to define the future of science itself.